In this lesson, we're going to talk about the margin of error, and we're also going to look at calculations that involve the margin of error. So when we're dealing with a confidence interval, we just talked about in our last video that this is our estimate. So for a proportion, that's our p hat. That's my sample that I found. And then I'm going to add or subtract the margin of error. So last time we looked at 2 multiplied by the standard error. This is called the margin of error. But I noticed that this is a z star, so it's not going to be necessarily 2, but we'll talk about more about z star in just a little bit. But this side of it is the margin of error. So that's what we're going to be dealing with in this video, is just that margin of error. So again, we're looking at a 95% confidence, so we can claim that the interval of p hat plus or minus 2 standard errors times 2 standard errors of p contains the true population proportion. So the extent of the interval on either side is called the margin of error. That means this is the margin of error, and this is the margin of error on each side. So in general, confidence intervals have the same form, estimate plus or minus margin of error. And so again, when we do this with means, our estimate will be our sample mean, our margin of error will be a little bit different. But the more confident we want to be, the larger our margin of error needs to be. So before, we were looking at a 95% confidence that went 2 standard deviations. That was 95. Now notice it's 3 standard errors away. So what does that mean? Well, that means we're more confident, but we're also less precise, because I'm making that margin wider, which means now I'm more confident that I'm actually going to capture that p, but I'm less precise because it's more values. So here's what I mean by that. Taking a look at tomorrow's weather, the high temperature will be between 40 below and 200 above. Well, clearly this weatherman is 100% right. It's going to be between those two unless we have some sort of apocalypse that happens. So he's saying, yes, this guy's never wrong, but notice we've sacrificed precision for confidence. So we're saying, yep, I'm confident that this is what the weather's going to be, but I'm not very precise. I can't necessarily decide what I'm going to wear tomorrow based on this guy's weather forecast. So again, in the 2, when we were talking about p hat plus or minus 2 times the standard error, we're using 2 based on the empirical rule. And remember, all along I've said the empirical rule is really just an estimate, it's not precise. And so instead, we're going to be a little bit more precise, and we're going to find a number that's going to replace 2. And that value is called z star. Z star is called a critical value. Remember this term, I'm going to talk about it a lot. Okay, so I'm going to show you using a table or technology covered in just a little bit. We're going to look at how to find this 1.96, but that is our critical value for a 95% confidence. So you can have any level of confidence that you want. These are the most common, the ones that you'll see most often. So if you see these, whether you're working on a case study or in MyStatLab, you can use these values as your z star. But if it's another value, or you forget about this video or whatever, I'm going to show you how to actually find it using technology. Before I do that, I want to talk to you about calculations with margin of error, because of course you're going to get several of these both in your case study and in MyStatLab. So if I want to calculate the margin of error for a 90% confidence level, and they give me a p hat and they give me an n, those are obviously very necessary. This is the formula for margin of error. Now z star, again, that's my critical value, and that's something I'd have to use technology to find, and I've found it to be 1.645. Again, I'll show you in a little bit how to find that yourself, but for now, just take my word for it. Now keep in mind, I'm only dealing with that right side. So before I was saying p hat plus or minus margin of error, this is the margin of error. So I'm not going to deal with that p hat right now, but I'm going to deal with the margin of error that I would add or subtract to that p hat. So the margin of error would be 1.645, which is my critical value for 90% confidence, times the standard error, which is my p hat, 0.4, times q hat. Remember, that's just 1 minus p hat, and that's how I found 0.6, and then over n. So just like we did before with PQ over N, now it's P hat Q hat over N. So really I'm multiplying all of this out, and finding that my margin of error is 0.02545, which means the margin of error is 2.5%, because remember, this is going to turn into a percent. This is the kind of question you get all the time. So now here's what our margin of error used to be, and now we want to reduce it to some certain number, or reduce it by half, or whatever. But we still want to remain 90% confident. Now it's, what must our new sample size be? So now we're solving for n. So notice here, I've taken the exact same formula I had before, which was margin of error equals z star and then p hat q hat over n. And I've plugged in 0.02 because this time they gave me the margin of error. The 1.645 came from 90% confidence, so that was the critical value for 90%. The 0.4, 0.6 remained the same. I'm solving for n. So now it's just a matter of doing the algebra. Now, if you're doing this in my stat lab, they're going to say, hey, use this formula and just plug everything in. If you're doing this for a case study, I want to know that you know how to do the algebra, so you're going to have to show me these steps. So again, the first thing I would do is get that 1.645 to the opposite side, because I don't want it over here. And then I have to square it, because squaring it will then get rid of the square root, because those two things are opposites. Now I'm trying to get n by itself, so really I'm multiplying by n on each side, which puts the n over here, and then I'm dividing by all of this, which puts that as the denominator. Then I plug all of that into my calculator. Now I want you to notice what I didn't do. I didn't take 0.4 and 0.6 and multiply them by each other, and then take 0.02 divided by 1.645 and square it. Like, I didn't do any of this and round in between, so that's the mistake most people make, is that they try to actually do some calculations in the middle, get it to this format, and then plug it all into your calculator. So our new sample size would have to be 1,624 to reduce our margin of error to 2. So typically we round up on those. Here's one more very similar question, but now notice I'm going to try to find z star. So it says what level of confidence, and level of confidence is what gives me my critical value of z star, was used if the margin of error in our original example was increased to 3.6%. So 0.036, everything else remained the same, original example, meaning the 10,000 or the 1,000 people that I started with. Again, the calculations here are a little bit easier. I'm just going to divide each side by all of that, and then of course plug it in. Now this part, I get 2.324, and again, it's very similar to 2.326. It's not exactly the same, but that was for the 98% confidence. Again, I'm going to show you technology on how we're finding those z stars in just a little bit, but that's essentially the work that you would do. So I would like you to press pause and try this question dealing with margin of error, and then press play to check your work. So if two people are running for an office, what sample size does it take to estimate the outcome of an election with a margin of error of 3% and 95% confidence? So for this one, notice they don't give me a p hat, but I have no idea who's actually running. So what can I use for p hat? Well, let's just say 0.5, because that's a safe bet. There's a 50% chance that this person will win and a 50% chance that this person will win. So that's what I'm going to use. Now again, we're looking for what sample size. So I'm looking for n. So I know that my margin of error is 3%, so that's 0.03, and then equals the z star is going to be for my 95% confidence. So that's 1.96. Again, I'll show you where to find those in a little bit. And then I'm going to use 0.5 over n. So that's how I'm going to set that up, is the 0.5. And then of course I'm just going to do all of that work like I did before, and I find 1067.11. So our sample size would have to be 1068 to have a margin of error of 3%.